Hi all, this is a demo of a PID review tool I've been working on. So hopefully this will appear on the ArduPilot tools web tools repository soon. So let's just have a quick look at it. So I'm going to load a file. Of course you need either rate or PID logging enabled, and you really do need fast attitude logging is what it's called on Copter, and on play, and it's called full rate attitude logging. So you'll be familiar with this flight data plots from the filter review tool. It's just roll, pitch, throttle, altitude, just a few sort of useful things. So you can pick out a section in the log if you wanted to just look at one particular part of the log, and just like the filter review tool, you can zoom in and then hit the calculate button, and you'll see we zoom in. So let's just go back to the default view. So we've got a number of axes here. So this has just picked up all the sort of PID logging messages. So we've got PID roll, PID pitch, PID yaw. So you can pick those, or if you've got the rate message there, you can pick the roll and pitch from the rate message. So we'll just look at the PID message first. So we've got target, actual, and error. So this is what you're trying to do, what did you actually do, and then what's the difference between them. So this particular vehicle is quite noisy. So you can see target is this smooth blue, error, actual here is the orange here, and then the error is shown in green. And then you can also see the components. So it's really very noisy, so it's a bit hard to see. So you've got, obviously the eye is quite small, no feed forward in this particular vehicle. And then we've got the D term, and then the output, which is just the sum of everything. Oh, and the P is the blue here. So you can sort of see how your vehicle is doing, and then what is making up all of the, or most of the noise. And you can see in this particular case, it's pretty obviously D. D is really driving the output. So that's that. And if we scroll down a bit more, you can see it's the same information in the frequency domain. So you can see target and then actual here. So target obviously drops off with frequency, and actual is a bit more, and you can see it's sort of a number of peaks here. So this is probably stuff that is sneaking under the notch filters and things like that. This 40 hertz here probably is that de-oscillation. So you can plot, you can turn on other stuff. Obviously in this case, the actual, the error closely follows the actual. You can plot the different components of the PID output. In this case, we haven't got feed forward, so it doesn't plot for us. And you can see D doesn't do anything at low frequencies, but then it contributes quite a lot at higher frequencies. You can see the A term does a lot at low frequency, doesn't contribute much at higher frequencies. But you see those notches or that noise coming past the notches is still in this log, of course, because the outputs are just calculated from the error. If it's in the error, you'll see that it's also in all of the others. You can also see, for example, if we turn off everything except the error and the P, right, that the P gain is just a multiplier on the error. So they're exactly the same, just shifted down the graph a little bit, about 0.3 is our P gain there. So you can sort of gain a little bit of insight by looking at the frequency components of your PIDs. You'll see here what your particular parameters were. So if you hover over, it says that parameter name, ATC ret roll P in this case. So, and the value. And then if I had changed the parameters in this log, you would get another line here. And then you could show sort of parameter set A versus parameter set B and do sort of A to B comparisons. You should work for as many parameter changes as you like. Unfortunately, it's only one log file at the moment, so future improvement would be to like upload 2 log files, and you could do a A/B comparison that way. Just like the filter review tool, we get a little bit of information, so logging rate 400 Hertz, and that gives us a frequency resolution of a bit less than 1 Hertz there. So you will notice that this by default uses a smaller window size. So we're down at 512 on 1024 on our FFT, just because it's not so fast, so you can still get quite a good frequency resolution by using smaller FFT window sizes, and then you get a bit more frequency time resolution. So the key thing that this adds that probably none of on none of the other ArduPilot tools have got is a step response estimate. So it takes the target and actual and then works out sort of an equivalent step response, and hopefully you can use this to tune the vehicle. So if you see this wildly overshooting, your gains might be too high. If you see it sort of ringing for ages, maybe you need a bit more D or something like that. So you can see the step response in orange here is just an average of all these gray responses. So it takes a number of windows through the flight and tries to calculate the step response. It can't always. So you'll see, for example, if we go and have a look at the pitch axis, there's not nearly as much moving about, which you can straight away see in this target and actual log. So you'll see we don't get nearly as many estimates, but you still get sort of a reasonable average here. But you can see some of them are way off. So we could probably get the average a little bit better if we sort of zoom into this little bit in the middle of the log where the actual movement's happening. You see that's slightly better. So by default, it just ignores any log or any part of the log with less than 20 degrees a second movement. So all of this flat stuff here would have been ignored in any case. So you can see that step response. We also get the spectrogram, so you can again, it's just the same FFT plot, but instead of averaging over time, you get the full time resolution. So that's the output. You can see that's the target and the actual. So nothing hugely exciting. You can see D does a bit more. And this is that portion of the log where we're moving about a bit more. You can see the I term, sorry, and starts doing a bit more when there's a bit more movement. You can clearly see those resonant frequencies here. There's this continuous 40 Hertz in there. No feed forward because it was 0, and then that's obviously the output. So hopefully the key thing here will be this step response tool. You can look at the Y as well. Again, we get a step response, and again, not quite so many points because there wasn't as much yawing. Maybe if we go to the full log, we'll actually do slightly better. Yeah, so now there's a few more sort of estimates here that then make up a nicer average. So that's that. I'll just quickly, so we've got both PID and the rate message. So we can use the rate message if you haven't got the PIDs. Let's go to roll. So now we just get target and actual. There's no error value logged, so we don't report the error, and we haven't got the components anymore. We've only got the output in the rate message, so we can't say what was P, what was I, what was D. So the rate message is often quite a good option because it doesn't make your logs nearly so big, but you lose out on having the individual components that you can plot. So you'll see they're grayed out here. I can plot the output and the target and actual. You do still get the lovely step response from the rate message. You will notice it's a little bit different because the target that we see in the rate message is not filtered. So we have a target filter. In this case, it's 20 Hertz. So this is unfiltered in the rate message, but in the PID message, the target is filtered. So there's a little difference. So that's the tool. Unlike the sort of filter review tool, the step response stuff is a little bit more experimental. And I will just say, so the equation and the derivation of the step response is from this PID analyzer tool from Plasma Tree. So that is where the original maths is from. That was a Python implementation, so I just re-implemented it in JavaScript. So thanks very much to them for developing that. And then, of course, PID Toolbox, which is probably well known to some of the people who fly Betaflight. So that is what sort of or shown the powerfulness of using the step response for tuning. And there are a number of excellent YouTube videos on the PID Toolbox YouTube page. In particular, there's a good video on how to get nice step response curves. So hopefully following these same instructions, it should work for the new ArduPilot step response function. So the key thing is that you really need to get a lot of movement, maybe 20 or 30 seconds of quite aggressive movements. And in this, my example log, there's only a few in the middle here, maybe just a little bit. So really, I think to hopefully get a better estimate, you need to really be a bit more aggressive on the stick, really throw it about and sort of stabilize to try and get lots of nice big data or big spikes in the data so you can get a much clearer step response. So you'll see in what's this? This is roll. So in roll, we've got quite a nice estimate here. You can see there's a lot of data. There's a lot of sort of shadowy lines here, and they're all quite close together. So you think, oh yeah, that's probably not too bad. But then if we look at pitch, where there's much less movement, only a little bit in the middle here, you can see there's not quite so many lines. They're all a bit more split up. So I think it's not, or you really need to do the right flight for it. So, and that's one of the things I haven't experimented with very much yet. So this is a little bit more of a work in progress tool and methodology than perhaps the filter tool is. So hopefully we can work out some nice methods to get really good logs that will work well with this step response, and then you can make comparable or comparisons between tunes in a much more objective way. So that's this new tool. It's still a bit of a work in progress. So things like changing parameters during flights and doing A/B comparisons, things like that, that should work, but it's not been tested extensively. So this is a little bit more rough around the edges than some of the other tools. And there's also some features that it really needs, like to be able to load multiple log files in and things like that. So you can really see that comparison between flights, and maybe you change some parameters and see how it goes. So that's the new PID review tool I've been working on. And I think the key feature that this adds is this step response. But I'm still learning how we can best use it, unlike the sort of filter tools where it was a much more clear-cut win. So hopefully this will be quite powerful and be able to really give a more objective sort of report or analysis of a tune. And I think to really make the most of it, we need to do those specific flights, as explained in this PID Toolbox video, to really get clean results so you can make comparisons as he is doing in this example. Thank you.